Hi everyone. In the last session I explained the topic in the chemical equations is what is the chemical reaction and what is the chemical equation and how to balance the chemical equations. In this session I explained the new topic, that is making the chemical equations more informative. That is making chemical equations more informative. Okay. In the chemical equation we have both the products and the reactants. The products and reactants both are separated by the arrow mark. The arrow mark separate both the products and reactants. The left side of the arrow mark we contain the reactants and the right side of the arrow mark we contains the products. Okay. This is the chemical equation. This is the chemical reaction. Okay. In this we can specify the states, then only the chemical equation can be more informative. First of all, in any given chemical equation, you have to specify the physical state of the chemical equation. This is the first step. You have to specify the physical state. Physical state. The physical states are how many types? These are 3 types. The first one is the solid state, the second one is liquid state, third one is gas state. Okay, the solid state is designated by the symbol S, the liquid state is designated by the symbol L, the gas is designated by the symbol G. When the chemical equation given, first of all you have to specify the physical state. The physical state is nothing but either it is the compound is in the state of the solid or state of the liquid or state of the gas. You have to specify. The solid state is specified with the symbol S, the liquid state is specified with the symbol L, the gas is specified with the symbol L. These are the chemical equations. You must have to specify this one. Okay. The Fe2O3, this is the solid. The aluminum, it is also solid. Fe, it is also solid. Al2O3, it is also solid. Next here the zinc. The zinc is the solid. Next H2SO4, this is the aqueous solution. What is the aqueous solution? What is the aqueous solution? The solution which is present in the water is known as the aqueous solution. The solution which is present in the water is known as the aqueous solution. The aqueous solution is specified with the symbol AQ. Okay, here the H2SO4 is the solution which is present in the water. Then only, that's why I am specifying the H2SO4 as AQ. Here the ZnSO4 is the aqueous solution. The H2 is the gas. In this next, carbon is the solid, oxygen is the gas, carbon dioxide is also gas. Next here the nitrogen is the gas, oxygen is gas, NO is the solid. Here the AgNO3, it is the aqueous solution, NaCl is the aqueous solution, AgCl is the solid, NaNO3 is the aqueous solution. Next in this, carbon dioxide is the gas, H2O is the liquid, C6H12O6 is the solid, the oxygen is the gas. Okay, when they are giving any chemical equation, first we have to specify the physical state. The physical state is nothing but either it is the compound is in the solid state or the liquid state or is in the gaseous state. The solid states are designated by the symbol S, the liquid states are designated by the symbol L, the gases are designated by the symbol G. There are some more physical state is there, that is the aqueous state. The aqueous state is nothing but the solution in the water is known as the aqueous solution. First you have to specify the physical state. Next, in the chemical reaction, it will generate some heat. It will absorb the heat. The heat generation and heat observations are represented by the symbols. Second one is heat generation. Some chemical reactions may generate heat. Some chemical reactions may observe the heat. Okay, the heat generation reactions are known as exothermic reactions. The heat observing reactions are known as endothermic reactions. Endothermic reactions. If in the any reaction the heat generate, it will designated with the plus Q symbol at the product side. The plus Q symbol at the product side. If it observes any heat, it will generate by the minus Q symbol at the product side. If it generate heat, it shows the product side as plus Q. If observes heat, it shows the minus Q symbol at the product side. Is it understood? First you have to specify the states, then you have to specify the exothermic reaction or endothermic reaction. The exothermic reactions are specified by the plus Q symbol at the product side, and the endothermic reactions are specified by the minus Q at the product side. Okay, is it understood? The next one, gases evolved. Gases evolved are specified with the up arrow. The gases evaluation is specified with the up arrow. In the any chemical equation, if the gases, the oxygen, nitrogen, carbon dioxide, hydrogen, these are all gases. These gases are represented by the up arrow, upward arrow. Okay. Here the gases are specified with the G symbol. Okay, or you can have to specify these gases with the upward arrow. Here the H2 is the gas. You have to specify either by G or upward arrow. Here the oxygen is gas. You have to specify the upward arrow or gas. Okay, you have to specify like this. Okay, the next one, some chemical reactions, the precipitate is created. The precipitate is created. The precipitate is nothing but it is the solution formed at the bottom. It is the solution formed at the bottom is known as the precipitate. The precipitate is represented always by the downward arrow. The precipitate is always specified by the downward arrow. In this the given equation, this is the silver nitrate. This is the silver nitrate plus sodium chloride gives AgCl. This is the white color precipitate. This is the white color precipitate. This is, that's why I am showing like by the downward arrow. Here the NaNO3 is the aqueous solution. The precipitates are represented by the downward arrow. Okay, next the fifth one is the any extra conditions. Any extra conditions. Extra conditions are nothing but temperature, pressure, any other things. These are the extra conditions. If you have any other extra conditions, you have to specify in the given equation at the above the arrow or below the arrow. Okay, in the last equation, the 6CO2 plus 6H2O gives 6C6H12O6 plus 6O2. Okay, in this equation, it will observe the sunlight and chlorophyll. That's why I am specifying the extra conditions as sunlight and chlorophyll and the above the arrow and below the arrow. This is used to, like this you have to specify the chemical equations more informative. For representing the chemical equations more informative, you have to specify the physical state and the heat generation and the gases evaluation and the precipitates and the extra conditions. You have to specify all these conditions on the chemical equations. Is it understood? The next one I will go to solve some more problems. Here this is the question, this is the problem. We have to solve this problem. Okay, here the chemical equation is already given. Al plus Fe2O3 gives Al2O3 plus Fe. What is the question here? Calculate the amount of aluminum. Calculate the amount of Al required to get 1120 kgs of Fe. Okay, required to get 1120 kgs of Fe. For this given equation, you have to solve the problem. The calculate the amount of Al required to get 1120 kg of Fe. First of all, you have to check the given equation is balanced or not. You have to check Al plus Fe2O3 gives Al2O3 plus Fe. Left side Al is 1, right side 2. Okay, you have to balance the equation. I am taking the 2 at the left side. Oxygens are 3, ferrous only left side 2, right side is only 1. I am taking the 2. Here the given equation is balanced. After balancing, you have to use what are the compounds are used here. You have to take the atomic mass of that compounds. The atomic mass of aluminium is equal to 27 units. Next, ferrous is equal to 56 units. Oxygen is equal to 16 units. Okay, first of all, you have to solve problem. You must know the atomic mass. Without knowing the atomic mass, you can't solve any problem. First, you have to learn about the atomic masses of for 30 elements. Okay, here what is the problem? Calculate the amount of Al required to get 1120 kg of Fe. Okay, 2 Al. Atomic mass of Al is 27. 2 into 27 plus Fe2O3. Fe2, 2 into Fe, 56 plus O3 means 3 into oxygen, 16 implies Al2O3, 2 into 27 plus 3 into 16 plus 2 into Fe is 56. You have to solve it. 2 into 27, 54 plus 2 into 56, 112 plus 48 gives 2 into 27, 54 plus 3 into 16, 48 plus 2 into 56, 112. 54 plus 112 plus 48, 160 gives 54 plus 48, 102 plus 112. The 54 units for aluminium, the 160 units for Fe2O3, 102 units for Al2O3 and 112 units for Fe here. Okay, in the moles formula, the 2 moles of aluminium plus the 1, here the mole is nothing but the coefficient you have to take in. Here the coefficient is 2, that is I am taking the 2 moles of aluminium. Here the coefficient is 1, that's why I am taking 1 mole of Fe2O3 gives, here the coefficient is 1 mole of Al2O3. Here the coefficient is 2, the 2 mole of Fe. Okay, the 2 mole of Al plus 1 mole of Fe2O3 gives 1 mole of Al2O3 plus 2 mole of Fe. Next, what is the question? The 54 units, the relationship you have to find out the aluminium and ferrous in the given equation. In this equation, the 54 units and means the 54 grams of aluminium needs 112 grams of ferrous. Okay, here calculate the amount of aluminium. We have to calculate the amount of aluminium to get 1120 kgs of ferrous. 1120 kgs you have to translate in the grams. 1120 into kgs means 1000 grams. Okay, here the cross multiplication takes place. 54 into 1120 into 1000 is equal to 112 into x. X is equal to 54 into 1120 into 1000 by 112. 112 ones are 112 tens are. That is equal to 54 into 10 into 1000. That is equal to 540 into 1000. That is equal to 540 kgs. This is the answer. Okay. Here calculate the amount of Al required to get 1120 kgs of Fe means the 540 kgs of aluminium is required to get 1120 kgs of Fe. Is it understood? Next I am going to another problem. Here this is the another question. Calculate the mass, volume and number of molecules of hydrogen liberated when 230 grams of sodium reacts with excess of H2O. Okay. The equation is sodium Na plus H2O gives NaOH plus H2. First of all, you have to check the given equation is balanced or not. Okay. The left side Na is 1, right side Na is 1, left side H2 hydrogen is 2 times, the right side hydrogen is 3 times. I am taking 2 here, I am taking 2 here. The given equation is balanced here. The next, what is the question? Calculate the mass, volume and number of molecules. First I am calculating the mass of hydrogen liberated when 230 grams of Na reacts with excess of H2O. Here we have to find out. What we have to find out? The mass of hydrogen. We have to find out the mass of hydrogen. First of all, you have to solve the problem. You have to know about the atomic mass. Atomic mass of Na is equal to 23 units. Atomic mass of hydrogen is equal to 1. Atomic mass of oxygen is equal to 16 units. Okay. Next, I am solving. Here, the 1 mole of Na plus 2 mole of H2O gives 2 mole of NaOH plus 1 mole of hydrogen. Okay, here the coefficient of Na is 1, that's why I am taking 1 mole of Na. The coefficient of H2O is 2, that's why I am taking the 2 mole of H2O. The coefficient of NaOH is 2, that's why I am taking 2 mole of NaOH. The coefficient of H2 is 1, that's why I am taking 1 mole of H2. Next, solving the problem. Na means 23 plus 2 into hydrogen. 2 hydrogens means 2 into 1 plus oxygen 16 gives 2 into NaOH 23 plus 16 plus 1 plus 2 into 1. 23 plus 2 into 2 plus 16 18 gives 2 into 40 plus 2. 23 plus 36 80 plus 2. This is for sodium, this is for H2O, this is for NaOH, this is for H2. Okay, the 23 units of sodium mixed with 36 units of H2O and it will give the 80 units of NaOH and 2 units of H2. Okay, here the 23 grams of Na needs how many grams of H2? 2 grams of H2. Here what is the question? 230 grams of Na needs how much hydrogen? The cross multiplication takes place. 23 into x is equal to 2 into 230. X is equal to 2 into 230 by 23. 23 ones are 23 tens are. Here, if this equation is not balanced, okay, here the Na is 2, that's why I am taking the 2. Here the 2 mole, 2 into 23. 2 into 23 means 46 plus 36 gives 80 plus 2. Okay, 46 grams of Na needs 2 grams of hydrogen. 230 grams of Na needs how many? 46 into x is equal to 2 into 230. 46 here, 2 1s are 2 5s are, 2 1s are 2 2s are 4, 2 3s are 23 10s are. Okay, 10 grams of hydrogen. Okay, here in this question the 46 grams of sodium needs 2 grams of hydrogen. Okay, 230 grams of sodium needs how much hydrogen? The 10 grams of hydrogen. This is the answer. This relationship is known as mass to mass relationship. The next one, here we have find to mass. The next one you have to find out The next one you have to find out the volume. This relationship is known as mass volume relationship. Mass volume relationship. The mass volume relationship is nothing but the 1 gram molar mass of any gas at STP 273 kelvins and standard pressure 1 bar occupies 22.4 liters. Here what is the relationship? In the equation, how many grams of hydrogen is there? In the given equation, 2 grams of hydrogen needs 22.4 liters occupies. Next, here how many grams of hydrogen is there? 10 grams of hydrogen needs how much volume occupies? Okay, the cross multiplication takes place. 2 into x is equal to, x is nothing but we don't know the answer, that I am taking as the x. 2 into x is equal to 22.4 into 10. X is equal to 22.4 into 10 by 2. 2 ones are 2, 11.2. That is equal to 11.2 into 10 is equal to 112 liters. This is the answer. This is known as the mass volume relationship. Here we have find the mass and volume. The next we have to find out the number of molecules. For the number of molecules is nothing but it is the volume to volume relationship. The relationship 1 mole of gas contains 6.02 into 10 to the power of 23 molecules. 1 mole of gas contains 6.02 into 10 to the power of 23 molecules. Here how many moles? Here how many hydrogens are there? 2 grams of hydrogen contains 6.02 into 10 to the power of 23 molecules. Here how many grams of hydrogen? For how many grams of hydrogen you have to calculate 10 grams of hydrogen. How much? How many molecules are there? Here the cross multiplication 2 into x is equal to 10 into 6.02 into 10 to the power of 23. X is equal to 10 into 6.02 into 10 to the power of 23 by 2. 2 ones are 2, 3.01 is equal to 3.01 into 10 to the power of 23 into 10. That is equal to 3.01 into 10 to the power of 23. Here the 2 grams of hydrogen contains 6.02 into 10 to the power of 23 molecule. 10 grams of hydrogen contain how many molecule? The answer is the 3.01 into 10 to the power of 24 molecules. Here we have specifying, we are calculate the mass. The mass is that 10 grams of hydrogen. The volume is 112 liters of volume and the molecules are 3.01 into 10 to the power of 24 molecules. The 10 grams of hydrogen contain 3.01 into 10 to the power of 24 molecules. This is very, very important question which comes in your board of examination. This is the end of this chapter. I hope you understand this chapter very well, chemical reactions and equations. I hope you are understood this chapter, chemical equations and reactions very well. If you have any doubts in this chapter, you have mentioned your doubts in the comment section. I will give the reply in the comments. Please subscribe my YouTube channel and press the bell icon.